Good day, viewers. You are welcome. How to solve these nice algebraic equations in form of trigonometric functions. We want to find the value of x that makes these two sides equal. We are given cos x equals tan x, and we want to find the value of x here. So the first thing we consider here is solution. So when you consider the solution from here, so from the given questions, we know from the left hand side here, suppose we have tan x. So this is a function which is the quotient of sine x and cos x. So having this, we are going to replace it in the questions, and we have cos x equals sine x divided by cos x. And by cross multiplying from here, so if this is divided by 1, then we cross multiply. So having this, we have cos x multiplied by cos x equals sine x. Then cos x multiplied by cos x, that gives us cos square x equals sine x. So by taking sine x to this left hand side, we have cos square x minus sine x equals 0. But we have to note that for every cos square x, suppose we have cos square x here, so this is the same thing as 1 minus sine square x. So by taking this identity, we are going to replace it as we have 1 minus sine square x minus sine x equals 0. Then let's try and rearrange this properly, as if this is minus sine square x minus sine x plus 1 equals 0. So by this, let's multiply throughout by negative, as we have this transformed to sine square x plus sine x minus 1 equals 0. So this looks familiar, as this is just like quadratic equations but in form of sine. So let's try and solve this one quadratically and see what will be the output of this equation. So if this is what we have, suppose we if I let sine x equals y, and this shows that by replacing sine x with y, we are going to have this as y squared plus y minus 1 equals 0. So we have a quadratic equation here, and let's try and solve this. So to solve this, we need some parameter here using quadratic formula. So we need a, which is coefficient of y squared, it is 1. Then we also have b, which is 1, and we have c here, which is minus 1. So on getting all these values, then we substitute it in this quadratic formula, which is y equals minus b plus or minus the square root b squared minus 4ac divided by 2a. So we try and substitute all these values here, and then we have our y here equals minus 1 plus or minus the square root of 1 squared minus 4 multiplied by 1 multiplied by minus 1, which is the value of c, divided by 2 multiplied by 1. And having this, we proceed by having y equals minus 1 plus or minus the square root of 1 squared, that is 1 plus. Then we multiply all this together, we have 4 times 1 times 1. This gives us 4, all divided by 2. Then we are going to have our y here equals minus 1 plus or minus square root of 5 divided by 2. So there are two solutions gotten from here. We have our y1 here, which is minus 1 plus or minus square root of 5 divided by 2. And also we have our y2 here equals minus 1 minus square root of 5 divided by 2. Then when we look up and we try to recall from here that we have our sine x equals y. So we try and replace it in the two answers that we get, and we see what will be the output of x. So when we plug it, we have, so let's try and substitute the first value of y here. We are going to have sine x equals, so for y1 equals minus 1 plus square root of 5 divided by 2. So since this is what we get, we are going to take the inverse of both sides, I mean the sine inverse of both sides. So when we multiply this one by sine, we have sine inverse multiplied by sine x equals sine inverse of minus 1 plus root 5 divided by 2. So when sine and sine inverse cancelled, what we have here becomes x equals sine inverse of minus 1 plus square root of 5 divided by 2. And this is our first answer to this problem. And actually, when we look at the second one, if y equals minus 1 minus square root of 5 divided by 2, this is a rejectable root. We are going to reject this. So because the ranges we consider here is minus 1, 1. So it means that this one is invalid for this, as the only answer is this. Thanks for watching, and don't forget to subscribe to this channel for more videos. See you in the next class. Never stop learning. Bye bye.